Hello everyone, I am Janus and welcome to the third video of our channel. As I promised earlier, today I will talk about the glorious scientific history of the special theory of relativity. So without further ado, let's explore. So the first fundamental question is, from when did it all begin? It was during the time of Galileo that the idea of space and time were firstly described using precise theoretical and to some extent practical proof. Later on, Newton proposed several laws of mechanics as well as space and time, which is taught even in schools today in form of Newtonian physics or classical physics. Newton's laws of motion are valid only in the inertial frame of reference, that is, at rest or uniform motion. In Newtonian physics, the concept of time is absolute throughout the universe. Newton's laws of motion are invariant under a Galilean transformation. When we go from one inertial frame of reference to the another, it signifies that the Newton's laws of motion remain the same across all the inertial frame of reference. It also implies that this law is universal in nature for all the inertial frame of reference. It also suggests that there is no absolute frame of reference and all the inertial frame of reference are equivalent in nature. Here, Galilean transformation is used to transform between the coordinates of two reference frames, which differs only by a constant relative motion. All these laws were thought to be the fundamental laws until a controversy arose. It was between the mid-1860s to the 1880s when a very bright physicist named James Clerk Maxwell proposed the Maxwell's equation, which helped to describe the behavior of charges at rest, charges at motion, electric fields and magnetic fields. It created a big problem. It suggested that if there are two observers in two different inertial frame of reference and they are both studying some sort of an electromagnetic event, they both of them would have to use the different forms of Maxwell's equation. So if there are infinite number of inertial frame of reference, then there are going to be infinite number of Maxwell's equations and its different forms. This gets rid of the idea of the universality of physical laws. Thus, Maxwell's equations are non-variant, that is, not constant under Galilean transformation. Now, what could be the possible explanation for this contradiction? It could either mean that Maxwell's equations are wrong or there is a flaw in Galilean transformation. Now, we can't really consider that Maxwell's equations are wrong because they are one of the most successful equations of electromagnetism and it easily passed the experimental test done to prove it. Maxwell's equations predicted the existence of electromagnetic waves, and light is form of an electromagnetic wave. This electromagnetic wave could travel at the speed of light, that is 3 into 10 to the power 8 meter per second in vacuum. Now, during that time, waves were also studied with respect to a medium. They had a velocity with respect to a medium. Now, since light was an electromagnetic wave, then what was the medium through which the light could propagate? What was the velocity of light with respect to that medium? For example, let us consider a wave or ripples in water. Then this wave has certain velocity with respect to the medium and is propagated through the medium of water. Then scientists hypothesized that light was traveling through an invisible, undetectable medium present everywhere in the universe, which was called as ether. Light traveled through ether at a velocity of 3 into 10 to the power 8 meters per second, and so in this condition, ether is considered to be as the absolute frame of reference and is detectable. But as we studied earlier in Newtonian mechanics that there is no absolute frame of reference, this contradiction was really such a pivotal point that it was really necessary to establish the existence of this ether medium. So two scientists named Albert Einstein and Edward Molly built the experiment. It was considered to be one of the most successfully failed experiments in the history of physics. The aim of this experiment was to prove the existence of ether by measuring the velocity of light in different directions or in different inertial frame of reference. I don't want to make this video very long, so in the next video we will continue this topic and learn about the Michelson and Molly experiment and how it failed successfully. So thank you guys for watching this video and see you in the next video.